Feels obvious, doesn't it? The universe is enormous. Our galaxy alone has something like 100 to 400 billion stars. Many of them have planets. Some of those planets might even look a bit like Earth. So we leap very confidently to the conclusion that advanced beings must be out there, building ships, stretching their cosmic legs, planning a visit. But here's the playful little question I want you to hold in your mind. Why do we think intelligence automatically leads to travel? That idea didn't come from a telescope. It came from stories. We grew up watching spacecraft land dramatically in deserts and cornfields. We imagine progress as a straight line, first tools, then machines, then rockets, then starships. It feels like a natural ladder. But nature doesn't build ladders with a destination in mind. It builds systems that survive locally. Think about this. Humans have been technologically advanced for, say, a century or two. And we haven't even managed to send people beyond our own moon for more than a brief visit. Mars? Still debating. The nearest star? That's 4. 3 light years away, about 40 trillion kilometers. At the speed of our fastest spacecraft, it would take tens of thousands of years to get there. So when we imagine aliens casually arriving, we're picturing a civilization that not only survives long enough, but also solves physics, energy, biology, and motivation all at once. That's a tall order. We assume arrival because we assume expansion. We assume expansion because that's what we dramatize. But the universe isn't written by screenwriters. It's governed by equations. And equations don't care about what makes a good movie. So before we ask, why haven't they come? Maybe we should ask something far more interesting. Is the universe even built for visitors at all? Now let's talk about something wonderfully stubborn, the speed of light. It's not just fast. It's the fastest possible speed in the universe. About 300,000 kilometers per second. Light can circle the Earth 7 times in 1 second. That's impressive. But here's the twist. Nothing with mass can reach that speed. That's not because we lack better engines. It's because nature says no. According to Einstein's relativity, as you push an object faster and faster, its energy requirement doesn't increase gently. It explodes upward. The closer you get to the speed of light, the more energy you need. And as you approach it, the required energy approaches infinity. Not a lot, not impractical, infinite. Imagine trying to push a shopping cart that gets heavier every time you shove it forward. At first it's manageable, then it doubles in weight, then it triples. Eventually it becomes so heavy that no amount of effort helps. That's how the universe treats speed. Now remember, the nearest star is 4, 3 light years away. If you could somehow travel at 50% the speed of light, a fantasy by our standards, it would still take over 8 years just to get there. And that's one way. No traffic, no detours. People often say, well, advanced civilizations will figure out faster than light travel. That's optimism sneaking past physics. Faster than light travel would require bending space-time in exotic ways, involving negative energy densities we've never observed in usable amounts. It's like designing a car that runs on imaginary fuel. Fun idea, no evidence. So here's the quiet reality check. The universe isn't built like a highway system. It's built like an archipelago of islands separated by oceans you can't easily cross. And that means something profound. Even if intelligence blooms all over the galaxy, the laws of physics may quietly ensure that most civilizations remain isolated. Not because they lack curiosity, but because the speed limit is absolute. All right, let's pretend for a moment that we're stubborn. We accept the speed limit fine. We won't reach light speed, but maybe we can get close. 10%, 20%. Surely a sufficiently advanced civilization could manage that. Now comes the part nobody puts in the movie, the energy bill. To accelerate even a modest spacecraft, something far smaller than a city, to a significant fraction of the speed of light requires an astonishing amount of energy. Not a lot in the everyday sense. I mean, energy comparable to the total annual output of entire nations, possibly entire planets. And that's just to speed up. You also have to slow down when you arrive. That doubles the cost. Then there's shielding, life support, redundancy systems. The numbers don't politely grow, they explode. Let me make this concrete. Imagine deciding to take a road trip where fueling the car would require draining every power plant in your country for a year. Not metaphorically, literally. You'd look at that plan and say, maybe we'll stay home. Civilizations, no matter how intelligent, must make trade-offs. Energy used for one project cannot be used for another. That's not philosophy, that's thermodynamics. Now here's the misconception. We imagine advanced beings with limitless energy. But physics doesn't hand out blank checks. Even if they harness fusion, even if they build Dyson-like structures around stars, energy remains precious because entropy never sleeps. And ask yourself something slightly uncomfortable. What's the return on investment? You travel for decades, maybe centuries, to reach another star. You arrive at a planet that may be uninhabitable, hostile, or already occupied by microbes. Was it worth it? Curiosity is powerful. But so is practicality. The universe doesn't forbid interstellar travel. It just makes it staggeringly expensive. And when something becomes expensive enough, most rational systems choose not to do it. So perhaps aliens don't arrive not because they can't, but because after doing the math, they decide it's simply not worth the bill. Now let's imagine the engineering works out. You solve propulsion, you manage shielding, you somehow pay the energy bill. There's still a quiet, stubborn obstacle left: time. Even traveling at an astonishing 10% of the speed of light, reaching the nearest star would take more than 40 years. That's just one way. At slower speeds, we're talking centuries, entire generations living and dying inside a ship. Now here's the part that really twists the knife. Civilizations don't stay the same for centuries. Look at us. 200 years ago, no electricity, no airplanes, no computers. Today, we carry supercomputers in our pockets. In a few more centuries, we may be biologically, technologically, culturally unrecognizable. So imagine aliens who detect Earth in the year 1200. They launch a mission. After a 1,000-year journey, they arrive only to find a completely different civilization, or none at all. The universe doesn't just separate us by space, it separates us by eras, and the numbers are brutal. Our galaxy is over 13 billion years old. Humanity has been technologically detectable for barely a century. That's less than 1/1,000,000th of its history. Two civilizations would have to exist at the same time, be close enough to notice each other, survive long enough to attempt travel, and still be around upon arrival. That's not impossible, but it's staggeringly unlikely. The real barrier may not be distance, it may be timing. We like to imagine that once a civilization becomes advanced, it's smooth sailing from there. Smarter technology, longer lifespans, greater stability, a steady climb upward. History suggests otherwise. In just over a century, humanity has developed nuclear weapons capable of ending global civilization and industrial systems powerful enough to alter the planet's climate. That's not science fiction, that's documented fact. Intelligence amplifies power quickly. Wisdom tends to lag behind. There's an idea scientists sometimes discuss called the Great Filter. It's the possibility that somewhere between simple life and galaxy-spanning civilization lies a stage most species fail to pass. Maybe it's self-destruction. Maybe it's ecological collapse. Maybe it's something we haven't imagined yet. Think about how fragile modern society is. Supply chains stretch across continents. Electricity grids are tightly interconnected. A few disruptions ripple globally. Complexity gives us power, but also vulnerability. Now extend that fragility to any intelligent species. The misconception is that advanced equals stable, but complexity often means delicacy. The more moving parts you have, the more ways things can break. If technological civilizations tend to last only a few thousand years before transforming or collapsing, then the window for interstellar expansion becomes incredibly small. So perhaps aliens don't arrive not because travel is impossible, but because longevity is rare. The universe may be full of brief sparks, civilizations that burned bright, then faded, long before they ever packed a suitcase for the stars. There's another assumption hiding in plain sight. If aliens are intelligent, they must want to expand, spread out, conquer the galaxy. But why? That idea says more about human history than about universal law. We often point to exploration as proof. Humans crossed oceans, climbed mountains, launched rockets. Surely any advanced species would do the same. But notice something. We didn't expand everywhere. Antarctica isn't full of cities. The deep ocean isn't packed with suburbs. Even Mars remains an expensive debate. Expansion only happens when the cost is justified. Now imagine a civilization thousands of years ahead of us. Maybe they've solved disease. Maybe they've built immersive virtual realities more compelling than physical travel. Maybe they can simulate entire universes inside computers. Why endure centuries of radiation and resource drain just to reach a distant rock? The misconception is that progress equals outward growth. But growth can also mean inward refinement. You don't need to conquer the ocean if you can build a paradise at home. There's also risk. Colonization spreads you thin. It creates conflict, instability, new vulnerabilities. Survival may favor consolidation over expansion. We romanticize star-faring empires because it feels heroic. But evolution rewards what works, not what looks impressive. So perhaps aliens don't arrive because they're not explorers in the way we imagine. Perhaps they reach a point where the galaxy stops looking like a frontier and starts looking like an unnecessary gamble. Let's take a breath and do something wonderfully unromantic: multiply probabilities. The Milky Way has somewhere between 100 and 400 billion stars. Recent observations suggest that maybe 1 in 5 sun-like stars could host an Earth-sized planet in the habitable zone. That sounds encouraging, optimistic even, but that's just step one. Now ask, what fraction of those planets actually develop life? We don't know. On Earth, life appeared relatively quickly, but that's a sample size of 1. Then ask what fraction of life becomes complex. On our planet, simple organisms dominated for over 3 billion years before complex animals showed up. Then ask what fraction of complex life develops intelligence. And what fraction of intelligent life builds technology? And what fraction survives long enough to attempt interstellar travel? Each step is less than 1%, and here's the quiet mathematical rule. When you multiply fractions, the result shrinks fast. We tend to add probabilities in our imagination. There are so many stars, we say. But the correct operation is multiplication, and multiplication is ruthless. The misconception is that big numbers guarantee big outcomes. But if each stage has even modestly low odds, the final number can become astonishingly small. It doesn't have to be 0. It just has to be rare enough that two civilizations almost never overlap in space and time. And when rarity becomes extreme, distance stops mattering. Isolation becomes the default. For decades now, we've been listening. Radio telescopes have scanned the sky, searching for patterns that don't look natural, narrow-band signals, repeating pulses, something that says, that wasn't a pulsar. That was intentional. So far, nothing confirmed. And here's where imagination rushes in to rescue hope. Maybe they're hiding. Maybe they use technologies we don't understand. Possibly. But notice what we're doing. We're stacking assumptions on top of an assumption. Let's start simpler. Radio signals weaken with distance. They spread out like ripples in a pond. The farther they travel, the thinner they become. After just a few light years, even strong broadcasts blend into background noise unless they're tightly focused. Imagine trying to hear a whisper from across a continent during a thunderstorm. That's interstellar communication. And here's another twist. Humanity has been radio loud for barely a century. Already we're moving toward fiber optics and directional transmissions that leak less into space. Our loud phase may be brief. If that pattern holds, then civilizations may shout for a moment, then go quiet. The misconception is that silence means absence, but silence can mean rarity, or distance, or timing, or fragility. The universe is not obligated to provide obvious signals, and when the sky remains quiet, it may not be a cosmic failure. It may be the statistical outcome of enormous distances, brief technological windows, and civilizations too far apart to hear one another. Sometimes silence isn't mysterious. It's expected. So now you might feel a little deflated. Are we really saying aliens don't exist? No. That's not the point. The point is subtler and in some ways more astonishing, even if intelligent life exists elsewhere. The universe may be structured in such a way that civilizations almost never meet. Physics limits speed. Energy limits ambition. Time limits overlap. Probability limits frequency. Each constraint alone is manageable. Together they form a quiet barrier. We imagine the galaxy as a bustling city. It may be more like a vast desert with rare campfires, each too far apart to see the others. And here's the philosophical twist I find most interesting. If aliens will never arrive, then this silence isn't an omission. It's a condition of reality. It means intelligence might awaken in isolated pockets, each wondering if it is alone. Perhaps every civilization looks up and asks the same question, and perhaps most never receive an answer. That possibility doesn't make the universe smaller. It makes our existence stranger. Because if no one is coming, no advanced guardians, no cosmic neighbors, then responsibility doesn't travel across the stars either. It stays here. Maybe the real Feynman-style reality check isn't about aliens at all. It's about us. If the universe isn't built for visitors, then whatever future unfolds among the stars will begin with the choices we make on this small planet first.